Hello students, welcome to my channel. My name is Darshan, I am your maths prof. So this is the third session of this third chapter, that is lines and angles and shapes. And in this session we'll see different properties of six different types of quadrilaterals. Quadrilateral is basically a shape, a polygon who has four sides. Okay, so now let me tell you, this session will be little bit of informative side, so you may find it little bit um, uh, boring, but I'm sorry for that, but this is the part of your curriculum. Just remember all the properties of these six different types of quadrilaterals, and once you remember all of them, it will be very easy for you to solve the questions. We'll see some 2-3 examples also in this session. So let's start. This is the first quadrilateral which we are talking about, and that is the trapezium. Trapezium has one pair of opposite side which is parallel. You can see here this AB and CD, they both are parallel to each other, right? So AB and CD are parallel to each other. So here I have written that one pair of opposite sides are parallel. Clear? And yeah, here this angle A and angle D, angle A and angle D both are co-interior angles. If you have already learnt about the co-interior angles, when two parallel sides or two parallel lines are intersected by a transversal line, then you must know that the co-interior angles are always supplementary. So this angle A plus angle D, that is sum up to 180, as well as this angle B and angle C, they are also co-interior angles, so they sum up to 180 also. Clear? And of course the angle sum property for the quadrilateral, that sum of all interior angles is always 360 here. Clear? Let's see the second quadrilateral, that is a parallelogram. Now this is very important, by the way, maximum questions you will find based on the parallelogram only. So here both the pairs of opposite sides are parallel and equal also. So you see this AB is parallel to CD as well as it is equal to CD, and AD is parallel to BC and they are equal to each other. So both the pairs of opposite sides parallel and equal. Then the opposite angles are also equal. Opposite angles are also equal. So if I say the angle A and angle C both are equal, as well as angle D and angle B, they are also equal to each other. So opposite angles are equal here. Adjacent angles are supplementary. So I can say that angle A plus angle B is equal to 180. They are adjacent angles. Similarly, angle B plus angle C is also 180, adjacent angles. C plus D is also 180. They are also adjacent angles. And angle D and angle A, they are also supplementary, so they sum up to 180. So this is how you see all the pairs of adjacent angles are supplementary in the case of parallelogram. Then comes the diagonals. If I talk about the diagonals, both the diagonals bisect each other. What do I mean by that? That if you draw this diagonal BD and another diagonal, that is AC. So if you see they are intersecting each other at that point, let's call this point M, and this M is the midpoint of AC as well as the midpoint of BD. So this is called, they are bisecting each other. Bisecting each other matlab they are intersecting each other at midpoint of each other. So basically the intersection point is the midpoint of each of them. Clear? And in the end, yeah, sum of all interior angles is also 360. So that is applicable for any quadrilateral we are seeing today. So this was the parallelogram. Both the pairs of opposite sides are parallel and equal. Opposite angles are equal. Adjacent angles are supplementary. Diagonals bisect each other, and angle sum property. Clear? Third, now this is the rhombus, and let me tell you, rhombus is also a parallelogram. It's a special case of parallelogram where all four sides are equal. In parallelogram, both the pairs of opposite sides are parallel and equal, right? But here in the rhombus, all both the pairs are parallel, of course, to each other, but all the sides are equal to each other, right? So this AB is equal to BC is equal to CD is equal to AD, which you can see on the diagram. And yes, of course, AB and CD are parallel to each other, and BC and AD are parallel to each other. So all four sides are equal. Now the property which we have already seen in the parallelogram are applicable here also, that opposite angles are equal, adjacent angles are supplementary, so that will be applicable here also. So all the properties of parallelograms are considered true for rhombus also, as well as it has another properties, and that special property of rhombus is, if you draw the diagonals, of course it's a parallelogram, so diagonals will bisect each other because rhombus is also a parallelogram. But here the catch is, both the diagonals are bisecting each other, of course, but they bisect each other at 90 degree. So that means this AC and BD both are perpendicular to each other. Both the diagonals bisect each other at 90 degree. Clear? So it is very important to remember this property, that both the diagonals are perpendicular, because in the I think that's the 9th chapter where we'll use Pythagoras theorem also, where this property will will be very useful. And yeah, angle sum property is always there for any quadrilateral. Sum of all interior angles is always 360. So this was the rhombus for you. It's a special case of parallelogram. All sides are equal, opposite sides are parallel to each other, opposite angles are equal, adjacent angles are supplementary, both the diagonals bisect each other but at 90 degree. Clear? Fourth one, rectangle. Again, it's a special case of parallelogram. So all the properties of parallelogram is true here. Moreover that, both the pairs of opposite sides are parallel and equal, which we have already seen in the case of parallelogram. So yes, that's true here. Moreover that, each interior angle is 90 degree. Each interior angle is 90 degree. So all the four angles are 90 degree each. And if I talk about the diagonals, if I sketch the diagonals, because rectangle is also a parallelogram, so that means diagonals bisect each other, that's true. But unlike rhombus, they don't intersect at 90 degree, but yeah, both the diagonals are equal, of course. Both the diagonals are equal and they bisect each other. So both the diagonals equal and they bisect each other. So AC is equal to BD, as well as this point M is midpoint of AC as well as midpoint of BD. Clear? And yeah, the angle sum property, angle A plus B plus C plus D is 360. Fifth one, that is a square. Square is it's a regular polygon and a regular quadrilateral. I mean, regular quadrilateral means a quadrilateral whose all interior angles are equal as well as all sides are also equal. So same like the rhombus, it has all sides equal, but moreover that its all interior angles are also equal. So you can say that it has the combination of the properties of rhombus as well as rectangle. Clear? In the rectangle we saw that all the interior angles are 90 degree, here also they are 90 degree. In rhombus we saw that all the sides are equal, here also all four sides are equal to each other. In rhombus we saw that the diagonals bisect each other at 90 degree, here also the diagonals bisect each other at 90 degree. And in rectangle we saw that diagonals are equal, so here also diagonals are equal. So all the properties which we have seen in other quadrilaterals are true here. So all both the diagonals are equal, they bisect each other as well as at 90 degree also. All four sides are equal, all four angles are equal to 90 degree. And of course all the sum of all interior angles is 360. That stands true for all the case of quadrilateral. Now in the end, sixth one, which is a little bit weird one, that is a kite. Now kite is a kind of quadrilateral where two sides are equal, not the opposite ones. You see, AB is equal to AD, two adjacent sides which are above the horizontal diagonal, they are equal to each other, as well as this BC is equal to CD. Clear? So AB is equals to AD and BC is equals to CD. Then if I say both the diagonals are not equal, they don't bisect each other. But yeah, this vertical diagonal AC, it bisects the BD at 90 degree. What I mean is this intersection point M, it is midpoint of BD, but it is not the midpoint of AC. So both diagonals don't bisect each other. Only this AC bisects BD. That means AC intersects BD in its midpoint. So M is the midpoint of BD and AC is perpendicular to BD, of course. Moreover that, if you see this angle, this whole angle B, and this whole angle D will also be equal, which we can get an idea by that similar and sorry congruent triangles. If you learn about the congruent triangles, we'll see in ninth chapter, I guess. Yeah, similarity, and in that case we'll see how this congruent triangles work and what are the criteria for congruent triangles. Right now just remember the property that AB is equal to AD, BC is equal to CD. Both diagonals don't intersect each other, both diagonals intersect each other, but not both are bisecting each other. AC bisects BD at 90 degree. Clear? And yeah, of course this angle A plus B plus C plus D is 360. There is one other property written here, that this AC, which you see the vertical diagonal, it's the angular bisector of angle A as well as angle C. So if I see this angle will be equal to this angle, because AC is the bisector of it. Angular bisector means a line which divides the angle in exactly equal to two parts, and this angle C is equal to this angle C. So that means this AC is angular bisector of angle A as well as angle C. Clear? So we have seen all 6 kind of quadrilaterals. If you don't remember, it will be difficult for you. Just go through all these 6 quadrilaterals again in this video, and I would suggest you to revise this video again and again, so that it will be easier for you to remember all these properties. Okay, let's see some questions based on these properties. See this one question. This is a parallelogram given, because PQ is parallel to SR and it is equal to SR also, and PS is parallel to QR and it's equal to QR. So both the pairs of opposite sides are parallel and equal. So that means it's a parallelogram. In the parallelogram, I want to find this X. Now let's see, if let's call this as Y, then Y will be exactly equal to 112, because we have already seen that vertically opposite angles are equal to each other, right? So Y will be 112, but we are not interested in finding Y, we want to find this X. So we have this property in the parallelogram that opposite angles of the parallelograms are equal. So I can say that X will be exactly equal to Y, because opposite angles of parallelogram. Okay, so X will be equal to 112 also. Clear? So this was a very easy question. Let's see another one. Yeah, so here it's a rectangle, and you already know that in the rectangle both the diagonals are equal and they bisect each other. So that means if this point is M, then it's a midpoint of AC also, and it's a midpoint of BD also, as well as AC and BD both are equal. So obviously their halves are also equal. So BM will be equal to CM, right? I'll write it here. BM is equal to CM. Reason, rectangle. In rectangle, both the diagonals are equal and they are bisecting each other. So that means BM will be equal to CM. Now if you see this BMC, triangle BMC, because BM is equal to CM, it's an isosceles triangle. In isosceles triangle, two angles opposite to the two equal sides are equal to each other. In isosceles triangle, two equal sides opposite angles are also equal to each other. So this X will be equal to 62. Reason, isosceles triangle. Clear? So this is how I found X, which is 62. Let's see another question. Yeah, so this is not any regular kind of any special kind of quadrilateral which we have seen in previous part of this video, but yeah, this is just any quadrilateral, a random quadrilateral. I want to find this x. Now you see, if this x, so this will be let's say y, so y will be nothing but 180 minus x. Reason is linear pair, because they both are on a same straight line, so this y will be equal to 180 minus x, both add up to 180. Now I'll apply the angle sum property of the quadrilateral, that sum of all interior angles is 360. So this y plus 90 plus 110 plus 50 is equal to 360. Remember one thing, in the case of 90, they will not give you this 90 degree. Instead, they'll give you the angle as a square like this. So you'll have to understand that the square means it's a 90 degree. It's a perpendicular. So yeah, so let's replace this y as 180 minus x from the result 1. So let's replace this 180 minus x plus 90 plus 110 plus 50 is equal to 360. Clear? So let's add all of them. 180 plus 90 is 270, 270 plus 110, that is 380, 380 plus 50, that is 430. So this is 430 minus x is equal to 360. Now let's make x as a subject, so x will be equal to 430 minus 360. Yeah, so x is equal to 70. Clear? Yeah, another one, probably the last one. Yeah, here this MNPQ, it's a parallelogram, because you see both the sides are parallel and equal. So obviously I can say that MN will be equal to QP. Right now it is given that MN is QP is equal to RN, but obviously it will be equal to MN also. Why? Because it's a parallelogram. In parallelogram, both the pairs of opposite sides are parallel and equal. Moreover that, this angle, let's call it y, so that will be equal to 98. Why? Because opposite angles of parallelogram are equal to each other, right? So this y will be equal to 98, and the reason is opposite angles of parallelogram, right? And yeah, so now in if you see the triangle R and M, this angle M will also be x. Why? Because R and M, if you see, it's an isosceles triangle. See, this Rn is equal to this Mn. If both are equal, then the angles opposite to the equal sides are also equal. So I can say that in triangle R and M, angle M also equals to x. Reason, isosceles triangle. And this y is exterior angle of this triangle. R and M triangle, if I'm talking about, then this y will be exterior angle of your triangle R and M. So if it's an exterior angle, we can apply that exterior angle property which we have seen in the last video, that exterior angle of any triangle is equal to sum of two opposite interior angles. So y will be equal to this x plus x. Reason is exterior angle property. Yeah, so y we have already found, that is 98. 98 is equal to 2x, because x plus x is 2x, so x will be 98 divided by 2, which is nothing but 49 degree. Clear? Yeah, that's all for this video. We have seen all 6 kind of quadrilaterals, and all the properties I have mentioned here. Just go through this video again and again and revise it regularly, so that you can easily remember all the properties. Once you remember all the properties, it will be easier for you. So at the end of this whole chapter, you'll have plenty of properties, properties like quadrilateral properties, 6 different types of quadrilateral. Then there are triangle properties, 4 different properties we have discussed in the last session. And then when two parallel lines are intersected by a transversal line, that is also mentioned in the first video of this chapter. And there will be other 6 videos of this chapter for the explanation part. So go through all of them regularly, and then we'll upload some past paper and important questions based on paper 2 and paper 4. You already know this is how we design the whole course. Clear? So I hope it was helpful for you. It was easy. Just remember all the properties. And till then, just keep practicing mathematics and keep supporting us. Please do subscribe the channel and like and share the video if it's helpful. Thank you.